Hello, I'm Jieshan Chen from the Australian National University. Today I will present our paper, Wireframe-based UI design search through image autoencoder. A well-designed GUI will make the application easy, practical, and efficient to use. It could distinguish an application from competitors, attract user downloads, reduce users' complaints, and retain users. However, to satisfy users' needs, designing a good GUI demands not only the specific knowledge of design principles and guidelines, but also the understanding of design space, which has the great variations in visual components, layout options, and the visual effect choices. However, according to a report survey of 5,700 developers, over half of them reported that they do not have much UI design training, but they are required to work on the UI design tasks. So an efficiency UI design search engine are required to help them. Let's see an example of how such an efficiency engine could help the developer to design the user interface. For example, a software developer, Lucy, are required to develop a mobile application for her startup companies. However, Lucy only has some desktop software front-end development experience, but never designed a mobile application UI. The first task is to design the sign-up UI for collecting user information, such as username, password. Here shows the initial draft of Lucy. There are some text view and edit text. Text view is for displaying a label for the information to be collected, and the edit view is for entering the information. However, Lucy are not sure whether her design is complete or trendy for the current mobile application. So he used such an UI search engine to search for relevant UI design in the real-world mobile application. Here's are the results she gets. And based on the results, she finds that she does miss some nice and important features. For example, the turn acceptance areas. The sign-up UI is a good place for the user to access and acknowledge relevant terms and conditions. So Lucy modifies her result and then search again and then refine repeatedly until she feels satisfied and confident for her design. From this example, we could see that such an efficient UI search engine could help the developer to design a trendy and useful user interface in an efficient way, and also could help them to gain a realistic understanding of the current design space. So there are three kinds of methods currently, namely keyword-based, image-similarity-based, and component matching-based method. However, although this kind of method could provide some initial design inspiration, they couldn't understand the semantic of the whole UI design, and they couldn't able to perform the UI search in a more targeted manner. Moreover, the image-wise, they will return design which are image-wise similar, but not design-wise similar. Moreover, since there is no label relevant UI designs, and it will require heavy manual effort to annotate such a dataset, we propose a method called wireframe-based image autoencoder, which trains a deep learning-based image autoencoder in an unsupervised way. Here's an overview of our approach. We first crop some applications from the Google Play Store, and then we develop a tool to automatically explore the GUI in each application and obtain the UI screenshot and the corresponding metadata. We then transfer the UI screenshot to the wireframe. Based on this UI design wireframe dataset, we can train our wireframe-based autoencoder model. Once our model trains, we can obtain all all latent vectors of our database. And given the query wireframe by user, we will first encode the query wireframe in our model and use the KNN search to search the relevant UI design in our UI design space. And here are some details. We crawled about over 54,000 UI screenshots and corresponding metadata from 25 categories of over 7,000 top downloaded Android applications in Google Play. And we select 16 core wireframe components by analyzing popular designers' tools and the underlying implementation details of UI, so that we could construct our wireframes. Using the metadata collected during the data collection process, we convert the UI design into the wireframe, into the corresponding wireframe. So here shows the structure of our model. Our model is comprised of several convolutional layers, downsampling layers, and upsampling layers. It takes as input the wireframe image and then encoded it into the latent vector. After that, it will reconstruct the latent vector. So our loss function is the MSE loss. Once the model trained, we use the latent vector to enable our KNN search. We consider 4 research questions. The first one is which kind of to decide which kind of the representation, which kind of method to represent each component in the wireframe. Should we use the gray colors or the colors or texture colors to represent different elements? The second one is regarding to the accuracy of our models. And also we consider to evaluate the generalizability and the usefulness of our model. I will only discuss the accuracy experiments due to the time limitation. We first, since there is no labeled dataset, we synthesize an artificial dataset. We consider 2 types of treatment to synthesize our data. The first one is component scaling, which will scale down all visual elements within the user interface. It simulates the design variations in component position and size. The second treatment is about the component removal treatment. It will randomly remove some elements in the user interface. It simulates design variations in component types and number. So here's the results of our models and other baselines. As we can see from this result, our model performs the best among all treatments, and our model is more robust in face of a large component scaling and component removal variations. And here are some results of our search engines. As you can see from this example, our model could retrieve not only the image-wise similar UI design, but also the semantic-like image design. We also evaluate the failure case of our search engine. There are 3 kinds of failure cases. The first one is that the query UI may contain several well-aligned close by same type components. However, the model only returns the UIs that have some same type but bigger and less number of components in the corresponding UI region, as we can see from this example. And the second type is that the query image contains a large component covering the majority areas of the UI, and the model will return the UIs which also have the same type big components but missing some small elements. And the last type is that the query UI contains some foreground UI components overlapping a large background components, but the returned UI contains only the background components without the foreground components, especially when the foreground and the background components are of the same type. So our model could be improved in terms of these 3 types of errors. Please see more details in our full paper. Thank you.
Hello everyone and welcome to the graphical user interface design session. I'm Ignacio Panag, I'm the session chair of this session. I'm a teacher in University of Valencia, Spain. And the first paper is called Wireframe-based user interface design search through image autoencoder. And the author is Yisan Chen, that is here to answer your questions. So please use the chat to transmit any question you have after watching the presentation. I will start with my own questions, and the first one is, how do you plan to measure usefulness and diversity of the recommendations?
Yeah, I need to share my screen.
Okay.
Can you see the screen? Actually, I have evaluated these two questions in my research question 3 and the research question 4. In the research question 3, I evaluate the generalizability to the real-world user interface to evaluate the generalizability and the usefulness. We sample 50 interface in each category and generate and retrieve the top 10 results from each method. And then we ask the 5 participants to rate the relevancies and the usefulness of each user interface. And to evaluate the usefulness of our method, we conduct another user study to show whether the results are diverse or useful. Yes, we pick daily UI daily tasks, including sign up, image gallery, login, and preference setting, and the navigation Java. And we ask about 18 students from our school to draw the wireframe for these 5 tasks, and they use our provided tool to retrieve the UI in our dataset. So based on this result, we evaluate our tools in terms of generalizability and usefulness. And the result also shows that our models could retrieve useful, diverse, and relevant user interface. And wait a moment. And here's some example for our user study. This is the first one is the wireframe that one of the participant draw, and the 10 user interface are the recommendation. And the user state a comment that if more different color example is better, I think it helps more. So we evaluate the result.
But are you using some questionnaire? For example, usefulness is very subjective because at the end, maybe what is useful for you, maybe for me, is not so useful. So at the end, the subjects, how can they specify what is the level of usefulness? Through a questionnaire or interview? Or what mechanism?
Okay, we use the 5 Likert scale.
Okay.
Since we have written some recommendation for our users, they can rate whether there are 2 aspects. The first one is whether the current UIs are relevant or not. So the first ties to a Boolean value, yes or no. And the second, for the usefulness, we use a 1 to 5 scale, and the 5 means the very useful, and the 1 means very unuseful. So we use this to evaluate the result.
Okay, thank you. Another question is that you focus your approach on 16 core wireframes. How difficult or easy do you think that a possible extension of the wireframes is possible? Can we extend the wireframes you are using, or is it difficult to extend?
Yeah, it won't be. Yes, this is the 16 wireframe components I selected from the popular designer platforms and the developer platforms. And actually, we just select these 16 components, and then we use different shape and colors to represent them. For example, on this side, this is the representation for the original screenshot. And since our method is quite easy, if we want to add more components, we just add one more shape to represent the new components and then convert the original wireframe into our format in the training dataset. And while training, we do not consider the details inside the UI. Our model is, we just fit the wireframe, the transferred wireframe, and then reconstruct it. So it will be super easy to add more elements to our dataset, to our existing components.
Okay. And have you studied the coverage of this set of 16 wireframe components? I mean, with these 16 wireframe components, what is the coverage for a usual interface?
Yes, you mean the correlation?
No, I mean, with these 16 wireframes components, do you think it's enough to design an interface? Or maybe there are some specific contexts where this kind of components are not enough?
Actually, we select the 16 components from the popular designer and the developer platform. And then we also calculate the frequencies of each component in our dataset. Wait a moment. Yes. We collected a large data set from Android application, and here is the distribution of each of the all kinds of components in our data set. As we can see, we select in the end of the graph, the components only appear less than 500 times. So the current selected components are representative for the most of the user interface.
Okay. And my last question is about your future work. What are your next steps in this research? Are you thinking in next steps?
Okay. Since for the current stage, we only consider the whole screen as the input. So the next step may be consider each element in the UI so that we could enable more smaller granularity search. We mean in a more targeted way. Maybe I only want to search the top UI, top part of the UI, and I don't want to consider the rest part. Yes, and then also I could consider more inputs to the current method to enhance the accuracy. For example, the text on the user interface or the categories of the current application. Those information might be helpful for the model to understand the semantic of the current UI, so that it could retrieve more relevant and useful and diverse user interface to the user, giving the wireframes.
Okay, Lisa, so we don't have time for more. If any else have questions, you can go to the discussion room directly and ask Jisan without me. So receive a virtual clap from all the attendees. Jisan, very well work. See you in the next session.
See you.